Hare Krishna. Hope you are doing well. Let's get started with this hypothesis testing question. Naturally, it will involve name and Pearson lemma because it's talking about the most powerful test, but it will also deal with the concept of minimal sufficiency in statistics and parameters. So let's get started. I have no shame in admitting that this is a part that I have generated from a prompt with Google AI, but essentially it's giving the premise of Neyman Pearson lemma that when you take the ratio of the likelihoods over here being the joint distribution, so it would be something like the joint distribution of x curl under theta naught and joint distribution of x curl under theta 1. Then when you are working with this ratio, then the most powerful test with the appropriate level will be of this form where alpha, which is the level or size, has it's equal to this thing, the ratio less than equal to some quantity under h naught. And yes, we can go about that way to construct it, but there's also a point of minimal sufficiency. Why I've put it in pitfalls? Because not knowing this concept could be a pitfall. It's important to know that when we are dealing with Neyman Pearson lemma, and if we are fortunate enough to use a minimal sufficient statistic, then the entire test can be constructed around that. Essentially, okay, over here, if you look at the distribution over here under theta naught, it's what? It's half to the power xi 1 minus half to the power xi, where I is going from 1 to 3 divided by this thing. It's going to be same product 1 by 4 xi 1 minus 1 by 4 xi. Now, sorry, here it would be 1 minus xi. So this thing you can see it just simplifies to half cube. So that thing cancels. This thing just is a constant. And in the denominator, if you look at it closely, the product thing over here would essentially make this something like half to the power summation of xi multiplied by 3 by 4, 3 minus summation or 2 raised to the power 3 minus summation of xi. So essentially it can be then seen also for this likelihood ratio, which is now completely a function of summation xi. If the likelihood ratio is to be less than equal to something, then this particular statistic, it is the same as saying that this particular statistic is less than equal to something. Summation xi is less than equal to something, because there is going to be a one-to-one monotonicity based mapping between summation xi and the likelihood ratio. So taking advantage of that, we only need to deal with this thing, and that is the part where we define y as the summation, and this is the value, this is the expression for size, where you are rejecting the null hypothesis given that it's true. Here it's just one value for the parameter under null space, so this thing is not going to be a supremum, otherwise size is defined as a supremum. Look it up. So this thing, when you look at it, it should strike to you with respect to the setup that you have constructed, that there's a binomial distribution with 3 comma half. This is 1 by 8. Okay, what can 1 by 8 be written as? This thing, of course. Because when you see that, when you internalize that, you can see that the only way this is possible is quickly when y is equal to 0, because it means x1 is 0, x2 is 0, x3 is 0, half 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 is the probability that adds up, which means this is going to be your critical region, and the power is rejecting the null hypothesis when the alternate is true, and you just under the alternate it's theta 1 by 4, so it's 1 minus 1 by 4 whole cube over here, and you get the answer. So that was it. This thing is necessary to give the context, but this thing is sufficient to solve the problem. That's the entire point. Take care. Hare Krishna.